Generative AI is all about semantic search. What it means is that when you are searching a text, the LLMs or the large language models, they return you the result on the basis of meaning of the text instead of keywords. For instance, in the previous era, when we used to do the keyword search on any document, the search engine would just return you the matching sentences with the keywords which you are searching. But with generative AI or in LLMs, what it does is it reads the whole document and then it returns you the sentences which have the similar meaning as your search terms. So this is what semantic search is. Okay. In this video, I'm going to show you how you can do the semantic search in Urdu language. Urdu is one of the most beautiful language in the world, I believe. And don't get me wrong, I love English and I still believe that it's a global language. But if you haven't really read about Urdu, I would highly suggest that if you're an English speaker, you should go and read some Urdu translations of poetry, prose, and there are a lot of stuff on the internet. Okay, enough with the Urdu praise. So let me start with setting up the stage for semantic search with LLMs in Urdu. Now, the first thing we need to do is to install some of the modules here, which is Cohere, and this is Cohere website, which I covered in my previous video, where you can do a lot of stuff with LLMs, and you can add AI to these your LLMs or products very easily with Cohere. In this video, I'll be simply using Cohere's API key, and for that, all you need to do is to go to cohere.com, and then on the left hand side, go to API keys and obtain your API key. That's all you need to do from Cohere. Then I'm using Google's Colab or Jupyter Notebook. You can play it on any Linux instance or AWS SageMaker Notebook instance or wherever you like. Okay, so let's install this Cohere and this Annoy library. Annoy is another very cool library, and Annoy stands for Approximate Nearest Neighbor. Oh yeah, so that is what Annoy stands for. And the purpose of this Annoy library, which is a C++ library with Python bindings, is to search for points in your text that are close to the given query point. Or in very simple words, it basically returns you the similar sentences what you are searching for. Okay, so as you can see, the Cohere and Annoy has been installed. Now in the next step, we need to set the Cohere with the API key which we have just copied, which I just showed you from Cohere's website, from here I mean. Okay, so once that's done, just run it and it will import Cohere and it will install it. Okay, I think I mistakenly ran the first one, but that is fine. Let it run. Okay, so let me delete this one, click here and run it again from here. That's done. Now let's import this stuff which we have just im- downloaded. So I'm importing the NI. I'm also using NumPy pandas, which are the usual standard libraries of machine learning. That's done too. Now, as we are dealing with Urdu, so I'm going to get this simple Urdu paragraph, which I just obtained from a Urdu newspaper, which talks about uh, government trying to build something and taking some decisions. And if you're a Urdu speaker, you would understand what this text is. But for the English speaker, it is just talking about some government trying to do some plans or developments. Okay, then we have chunking of this text which we have just pasted. I also have another video around chunking, and if you don't know chunking, I will drop the link to that in video description. But in a very simple words, chunk basically refers to the amount of text which your large language model can handle in the context. Or in simple words, just like humans have a memory and they have a certain context which is limited. You can't really encompass everything in the world or in your brain at the same time. You have just a small context, a limited context whenever you are talking about something. Same goes for the LLMs. So when LLM is dealing with some data, it just limits the context or the amount of data it can handle at any certain given point in time. So in this line of code, what we are doing it, we are splitting this paragraph into sentences with this delimiter which is dash, and then we are removing the spaces from here. So what happens is that it converts this text into manageable sentences which LLM can handle easily. So that's all it is doing here. Okay, so let me run it. It has given me an error. It says text is not defined. Okay, so I think I needed to give um, text here. Okay, I didn't run it, so let me run it again. The text one, that's done. Now come here. Let's run it now. Okay, this works now because I forgot to run this variable where I was assigning this text. In the next one, I'm going to create the embeddings. Embeddings is another concept in machine learning or artificial intelligence. So obviously, the LLMs, they don't understand what the heck this thing is, or in any other language. They convert this text into numerical representation. That numerical representation is vector, and those vectors are called as embeddings. So we need to create those embeddings, and this is where we are using this which we which is a basically cohere client. So we are using cohere client to convert this text into numerical representation, which will be easier for our LLM to understand. So that's done. Embeddings are created. Next, let's check the shape of this embeddings, which means that the sizes and stuff. Let's see how many we have. Let's wait for it to finish. So we have, this is a vector shape, a numerical representation. Now just throw this thing into an index so that it will be easier to search. And this is a code to throw all these embeddings or numerical representation into index. And index enables us to search it quickly. So it's true. So index has been built. Now in the next step, what we need to do, we need to use pandas to make it to format the results, whatever we'll be searching. And this is a code we are using. So you can see that first we are getting the embeddings, then we are retrieving the nearest neighbors, which is again with the library, which does exactly that. And then we are formatting that result with the pandas, and then we are returning the result. Let me run it. Cool. So this is all we needed to do. Now it's time to test this code. And then, so here I'm the test, we already have it. Now the query I'm sending is um, what decision did government take, or हुकूमत ने क्या फैसला किया in Urdu. So let's see if it is able to return me the result from that document. Let me run it. Okay, so here you go. So this is the whole text we used, and these are the three options it has returned, and it has ranked them. You can see, and it has ranked them in the order of distance. This has the closest distance with our question. With this question, this has the closest distance, and it is spot on, bang on target, because if you read this text, it says हुकूमत ने तजारती मैदान के लिए बिजनेस पार्क्स कायम करने का फैसला किया. And so we have this फैसला keyword here, and then hukumat, and then it has calculated its semantic, and then it has returned us that this is the most likely or most nearest neighbor, which is correct. And then there are other nearest neighbor it has found. But all in all, you can see that this um, code has returned us correctly the nearest neighbor from out of that text. Now here is the great thing about this is that you can use any language you want. All you need to do in this code is to go up and change your text here, then come down and change your question here. Maybe French, German, Hindi, or whatever you like. So I have used Urdu here, but you can use any one of you want. So that's it. I will post all of the commands I have used in my blog, and I will drop the link to that blog in video's description. And I hope that you enjoyed it. I loved it, and you can see how easy it is to build your own products around it, and even your company's data you can throw in it. If you like the content, please consider subscribing to the channel. That helps a lot. And thank you very much.